Welcome to EDU World Space.
Everybody, so we need to determine the mass products of inertia, y, z. So we need to do xy, inertia of y, z, and inertia of zx, the steel fixture. So that kind of looks like, and I'm gonna try, and let's just do red for here. Okay, and this is going to be 1. And we have this here. And we got this here. And we're actually just going to use this black to kind of draw where we should have this. Okay, it's not the perfect box, but that's okay. And then we're going to use green to kind of draw the second part, so you guys can kind of see what this looks like. It's not perfect, obviously. Actually, we're just gonna then do this solid, and we're just gonna close that up a little bit because we do have this. There we go, a lot better looking. And now we have 3, which is, again, I'm gonna try to get this thing to look decent. There we go. We got 3 and we got 2. Okay. Now that's picture is done in the way. It's not beautiful, but it's okay looking. We got this. So to calculate the mass of component 1, we have M1 equals the density in B1, and this equals density times L1 H1B. And the densities of the steel, okay? So what we can do is now plug everything in. So 7850 times 160. It's going to be 160 times 50 times 80 because that's the mass times length. That's the for height, length, and for the B. Okay, so math time. That's just simple. And we need to convert this. We got 1,000 millimeters. This is going to be cubed. And this is cubed. So we get 5.024 kilograms for that. And we got to do the second one as well. And the second one's obviously the green one. And this one is going to be density times volume. Oops, density times volume 2. So we'll look at the second one. And this is going to be PH2L2B, which is 7850. So we're still looking at the steel density. So 38 times 70 times 80, because that's the base. So B is the bottom part here. And we get the height. And we have the length, okay? And, oops, I almost forgot. We have to convert it. So M3 over 1,000 M3, and we get 1.670048 kilogram. Okay. And now we got to calculate the mass. So the mass of the third one, volume 3. This one's going to be a little bit different because you obviously see the curve here. So we're going to keep that in account. So we got pi squared r squared L3. And so this is going to be 7850 times pi squared times 24 divided by 1,000. So we're going to convert it times 40 times 1,000. And this person equals 0.2841 kilograms. And now here the central mass of inertia are going to be 0 because of symmetry. Okay, so your I mass y equals 0. Your inertia mass x 0. Your inertia max sub z is 0. And we gotta calculate the distance of the center of gravity, and this is center of gravity is y2 h1 minus h2 divided by 2. So this is going to be 50 over 1,000 minus 38 over 1,000, because we're again just sitting there converting it, and that's what 1,000 is converting it to meters. Okay, and this is going to be 0.031 meters. And we need to do the center of gravity for the third one, which is going to be h1 minus 4r 3 pi. Because again, it's a curve, so we have to do a circular part. We have 50 over 1,000 minus 4 times 24,000 divided by 3 pi. And we get 0.039814 meters. Okay. So now we have to do is your inertia mass x, y of the first one, and this is going to equal to I max y plus m x1 y1. And this is obviously going to be 0 plus 5.024 times 10 to negative 3. And so your answer is going to be 5.024 times 10 to negative 3 kilogram times meter cubed. And what we're using is calculate a table with values as shown in the table. So what we have is, I'm looking at a table. So if you're curious where I'm getting the information, it's just a table that they give you in the book. And so we have the next one, ms xy of 2. And this one is going to be the same thing here. It's going to be 0, so I'm going to do mx to y2. And according to the table, this is just going to be 2.0714 times 10 to negative 3 kilograms per meter cubed. And for the third one, it's going to be 0 plus mx. So I'm just going to write 0.4524 times 10 to negative 3 kilograms times meters squared. Okay. And now to calculate the mass products of x, y. And to do that, we have I mass x, y. And we have section. And it's just going to be I m s x, y 1 plus, and I'm just going to write m x, y 2 plus inertia and x, y 3. And we're just going to add all of these up. So 5.024 times 10 to negative 3 plus 2.0714 times 10 to negative 3 plus 0.4524 times 10 to negative 3. And from this, we get 2.5 times 10 to negative 3 kilograms per meter squared, and that's your xy. And now we can do your I of y, z. That's what you want. And we're just going to kind of just do the exact same thing that we did above. And we're just going to find y, and that's going to be 10.048 times 10 to negative 3. I, y, z2 is just going to be 4.4017 times 10 to negative 3 kilograms meters squared. And I, y, z third is just going to be 1.5836 times 10 to negative third kilograms meters squared. I've got kilograms meters squared. Because you're just doing m times y times z, okay? And so your total, which is the one we're looking for, is just going to be all of these added up. So we have 10.048 times 10 to negative 3 plus 4.4017 times 10 to negative 3. We're just going to put parentheses. Plus 1.5836 times 10 to negative 3. And we will get 4.06 times 10 to negative 3 kilograms per meter squared. And now we just have to do your ZX. And your ZX1 is just going to be 16.068 times 10 to negative 3. The second one is just going to be 5.6796 times 10 to negative 3. And your last one is just going to be 1.59110 times 10 to negative 3. And then your total one is just going to be all those added up. So 16.0768 times 10 to negative 3 plus 5.6796 times 10 to negative 3 plus 1.5910 times 10 to negative 3 equals 8.81 times 10 to negative 3 kilograms per meter squared. Okay? And those are your answers, guys. Thank you.